Hello students, today we are going to discuss about different addressing modes and formats of addressing modes. Okay, this is an important topic. So see here, what is an addressing mode? Suppose if you are defining it very formally, so different ways of specifying the location of an operand in an instruction. So it is called an addressing mode. Okay, let me explain with example. Suppose if I have given two operands with an instruction that is equal to add. So here I am using that is add and A comma B. So, okay. So this is A and B. These are the operands in general way. Suppose if these are 3 and 5, okay, add 3 comma 5. So what will happen? It will add 3 plus 5 and it will store the result of 8. Okay. So here, so what we are going to do, so for getting these 3 and 5, where it is located, you know this, you need to use the addressing mode. Whether these operands are stored directly or indirectly, or it is an array, or it is a pointer, where to specify the location of an operand. Okay. So in an instruction, we use addressing modes. Okay. So that is the necessity of addressing modes. Okay. So different types of addressing modes are available. Only in previous lectures, what is direct addressing, direct address, and what is an indirect address. Here we will see some different ways of addressing modes here. Okay. According to the processor and the system memory and the instruction architecture, these addressing modes are dependent. Okay. So see here, these are the different types of addressing modes here. Normally in any system architecture, they used these are the different addressing modes we normally see. Okay. So addressing modes are depending on the system instruction system architecture, instruction set architecture. Okay. Suppose different system architecture, and that is instruction set architecture. One is CISC and second one is RISC. Okay. What does it mean, RISC and CISC? CISC means complex instruction set architecture, and second one is the reduced instruction set architecture. Okay. So these addressing modes depending on which instruction set your computer is using. Suppose if it is using complex instruction set architecture, it may use 8 to 10 addressing modes. In CISC, it may use 8 to 10 addressing modes. Okay. And suppose reduced instruction set architecture, if it is using, so it may be used up to 5 addressing modes only. Okay. In reduced instruction set, it used only 5. And these addressing modes will be depending on your processor also. Suppose if it is in x86 processor, that it is Intel x86 processor, it may use some other addressing modes. All these 12 addressing modes are 10 addressing modes. Otherwise, if it is the ARM processor, then it may reduce the addressing modes. Okay, according to its processor and instruction set architecture and your memory, how much memory size if your system is having. So these addressing modes depending on these three things: memory size and your processor type, and which instruction architecture, your instruction set architecture you are using. So these addressing modes will be depending on that. Okay. So normally these are the main addressing modes. Okay, one by one. So this is immediate, direct, indirect, register, register indirect, index addressing mode, relative addressing mode, auto increment, and auto decrement. Okay. So these are the 9 or 10 addressing modes, main addressing modes we need to know about this. Okay. So in different addressing mode, different way we need to calculate the address of an operand. Okay. So one by one we will see. The first one is the immediate addressing mode. Okay. So immediate addressing mode, what is the address? What is the address here? Suppose this is the instruction. Okay, example, add 5. Okay. So what does it mean? It will 5. That means it will, here there is no address specified here. Itself, it is an operand. It will act as an operand. That's why it is called immediate addressing. Okay, this 5 will be added to accumulator. Why it will be added to accumulator? Because accumulator is a default register. It's a default register. Okay, if anything, if you want to add, it will add directly to the accumulator. Okay, so what will happen, that is the accumulator will be always denoted with the AC. So AC implies that is equal to, already in AC, what will be the content? It will be add with 5. Okay, it will add with 5. This is the actual, that the meaning of this instruction. Okay, suppose already accumulator is containing the 7. So 7 plus 5, it will be adding, and what it will store? It will store the 12. Okay, here there is no specification of address. In immediate addressing mode, we need not to specify the address. Here itself we can say it is an operand. Okay, so here no memory reference to fetch the data. Here we are not mentioning the address, so no need to fetch the, no need to specify the address of the data. Okay, and limited range, it is advantage is very fast, but it should be limited range. All instructions should not be immediate addressing. Okay, so here what will happen? Opcode and operand. Here operation code is add, and what is the operand we specified here? That is 5. Okay, so what does it mean? It will add the 5 operand to accumulator. So this instruction meaning is like this. Okay, so this is the immediate addressing mode. And next addressing mode, suppose if you are looking the next addressing mode, C, that is direct addressing. Here we need to know what is the effective address of this. Okay, effective address means actual address of an operand. Okay, so suppose here I have given add A. Okay, A is not the operand. Okay, so see here, I will explain with through diagram here. So here upcode operation code is equal to add. Okay, here I'm giving you, this is add. Okay, and here we will specify the, in the form of address. Suppose A is specifying suppose 3. A is specifying 3. That means here how many? 1 locations are there. Here for example I'm saying this is 1, 2, 3. This is 4 and this is 5. Okay, and here it is specifying third location. Address A means it will not say like this. A means it will specify third location. Okay, so here it will go to the third location, then it will fetch the operand. Okay, then it will fetch the operand from that. That means in direct address, add the contents of cell A. That means A means in the third location. Example, for example, I'm saying from the third location you fetch the data. Okay, so where it will go? Look in the memory at the address A for operand. Okay, so here how many memory references you need? Here it is specifying third location. It will go to the third location and it will fetch the operand, and it will fetch the operand. That means one memory reference it is required in direct memory address. Okay, so that means single memory reference is required to access the data, and there is no additional calculations to work out the effective address. Okay, here we are mentioning the address directly. Go to that location and fetch the data. So that means effective address is only, no need of calculation. Again, we need to add something. Nothing we are doing here. We are directly mentioning the address. That's why it is called direct addressing. Okay. And what will be the disadvantage for this? Limited address space. Okay, in this direct addressing mode, the disadvantage is limited address space is the disadvantage, because if you have a memory, less memory, then a limited address space will be available. Okay, so this is the direct addressing mode. In the first mode, that is immediate addressing mode. Next addressing mode we already explained, that is direct addressing mode, and third addressing mode, that is indirect addressing mode. So see, I will explain this also through diagram, then I will come to this point. Okay, so see here in the indirect addressing mode, here we need indirect way we are specifying the address. Okay, so here this is the operation code, suppose add. Okay, in the last previous example also I have taken add only. So here also I have taken add, okay, add, and address is specifying, suppose first, okay, here in this points to first, okay. So in this point, again, it is specifying the third location. That means this is 1, this is 2, and this is 3, and this is 4, and this is 5, for example, okay. And here address is specifying 1, A is equal to 1, it is specifying, okay. Suppose if it is specifying 1, it will go to the 1. So in 1, what is the operand? 3. So then again, it will go to the 3, okay, third location. Then here, suppose if it is operand is 100, then it will fetch the data, okay. So what will be the effective address here? 3 is the effective address. This will be the effective address because actual address of the operand is called effective address. Okay. So what is the actual address here? 3 is the actual address. Okay. Because 1 it is specifying here, but in 1 it is not a direct address. It is going to fetch in first location, it is going to fetch the data 3. Then again 3, that location it will go and it will fetch the data. How many memory references it requires? 2 memory references. This is the first reference. This is the second reference. Okay. So 2 memory references are required here. So now we are coming to the theory part. Memory cell pointed to by address field contains the address of the operand. Okay. Effective addresses means what? This is EA is equal to the content of A. The content of A. Okay. So look into the A, find the address and look there for the operand. Okay. So see here using this. First of all, A is equal to 1. Under 1, that means in brackets, if it is showing the content of 1, what is the content of 1? It is 1, it is containing 3. So this is 3. Okay. And the content of 3 is equal to what? It is equal to 100. Okay. So the data will not show in the bracket. If it is showing in the bracket, it is the address. Okay. So what is the effective address? 3 is the effective address. Okay. So 1 is equal to 3. 3 also it is address. It is not the data. In 3, it is the data. Okay. So here we will see EA is equal to the content. In brackets, it is showing. It is the address. Okay. This is called the indirect address. Okay. It is used for points, pointers, nested loops. Suppose if you are using, then multiple memory access to find the operand. Okay. So multiple memory access we required here. So that's why it is a slower operation. Okay. Hence it is a slower. Direct access is in address is the fast address access, and it is a indirect address access is a slower one. Okay. So this is about the third addressing mode. Okay. In the next class, the remaining addressing modes we will be sharing. Okay. And remaining addressing modes also, there are 6 more addressing modes are there. So we will be explaining in I will explain in the next class. Okay. So addressing modes will be using for to locate the operand of an address, to locate the address of an operand. Okay. And it is very important because we need to find any operand address. The addressing mode is very important, and addressing modes are depending on the instruction set architecture and the processor and the memory size we are going to use. Okay, thank you. I hope you understand.